Greetings everyone, I'm Stephen Las Marias, editor of Times Asia, and we're here at Computex 2026. I'm at Infineon's booth, and joining me is Jimmy Cho, Director of Product Marketing, to discuss their technologies being showcased here at the show. Jimmy, thank you very much for this opportunity.
Okay. Hi, Stephen. Yeah, good to see you here. Today we in Computex we're showcasing the latest USB general purpose controller here, and it's been a while since the Cypress Day coming to Infineon that the focus for the past 10 years, and it's been shifting in the power delivery part, and now coming back to the data controller that we're trying to really coming back to enable that the application that can leverage the super fast USB 20 gig bandwidth. Especially now we're talking about this AI, right?
Yeah.
Physical AI. I think this is going to play an important role that we can talk about later.
Okay, right. So, Jimmy, for the benefit of those who may not be familiar yet with the company, maybe you can tell us a little bit something about Infineon and your role.
Okay, so that's a big question. That Infineon is such a big company with 60,000 employees and there's so many product lines here. Me myself represent the USB data product here at Infineon, and this entire product really coming from the acquisition of Cypress Semiconductor 5-6 years ago, right? And Cypress Semiconductor started USB since 1996, so it's been a leader in the USB community industry for a very, very long time, almost 30 years, right? And actually, this year is pretty interesting. We actually celebrating 30 years of the USB, right? And everything started from 1996, right? So now with the leadership in the USB industry, that we're trying to make sure that the ecosystem, right, really align with the trend of this AI things. Make sure that the USB continue to grow into the next generation for the future, the faster and higher bandwidth.
All right. So Jimmy, we're here at Computex, right? And then Taiwan is a major center for OEMs and ODMs, right?
Yeah.
So from your perspective, what are the biggest system-level challenges OEMs face today in sustaining reliable, high bandwidth USB performance?
Okay, that's definitely a good question. I think I don't know if you guys are aware that for the past 10 years, right, the application in the USB high bandwidth, really not grow whole lot. You see a lot of storage device like SSD, right?
Yeah.
But you don't really see like super high bandwidth 10 gig camera or capture card so the thing is like this critical building block that the people need to design high bandwidth USB product really it's not there. It wasn't not there, right? And so the whole industry, for the USB industry, sort of slowed down,
right?
In terms of the evolving to the new USB 4, right? Yeah. So what we're doing here is we're providing this critical building block, so people can easily adopt into their application, providing this interface between their device can be data source or sync, right, and to the new computer, right, or the new embedded system like NVIDIA, right?
Yeah.
So this is so it's been a problem for a while until now that we provide this simple building block and the easy development tools, so the people could just easily build it. Today.
Right.
Yeah.
Okay. So Jimmy, among your demos here at the Computex, this is your USB 20 gig over 6 to 7 meter cable. So from a signal integrity and power delivery perspective, what engineering innovations enabled this capability?
Okay, so typically when we talk about cable lengths, right?
Yes.
We talk about passive cable, right? And we know there's retimer, AOC, right, that can extend the cable length to 20 meter, 30 meter, right? But more important is when we want to talk about signal integrity and the performance of the physical layers of the chip, right? Really, so Infineon we designed this the new USB 3.25 from ground up, right? So what we did is the enable the receiver to support up to 28 dB insertion loss, which translate to long USB cable, right? So I don't know you're aware that the so typically we know that the higher speed meaning shorter cable, right? And you look at Thunderbolt cable, right? So maybe at the 0.8 meter, right? And you look at the USB documentation. They talk about 10 gig only for 1 meter cable. But today, now only 1 meter, not 3 meter, right? We officially proven that the 5 meter cable, passive cable capability for 10 gig or 20 gig, right? So here we actually showing. So the way to show robustness of this long cable is we want to show longer cable capability.
Right.
So officially we say 5 meter. We'll showcase 6 meter, a 20% longer cable. Right. So for that, I think that can enable a lot of application like machine vision camera, right, or embedded camera that so they can have this long cable routing capability from their camera to the system. Right. So this is the how we really solve the signal integrity problem, which has been a big problem for this industry for a long time, right? And also, you talk about power delivery, right? For Infineon, right? We're really big in the power delivery controller, right? So this is things like not only the long cable we got to worry about, right? So these things like how you get more power from your whole side, right? So I think we're working on the this whole ecosystem to provide a new kind of capability, including our PD controller on the whole side, to provide different, even higher voltage that the typical 5 volt that host can provide. So that's the things that the whole industry can benefit for next 10, 20 years that they have longer cable, higher bandwidth, and more power to use.
Right. Okay, another demo, Jimmy, was the HDMI 2.1 4K 120 video capture with HDMI out. So which emerging use cases are driving demand for low latency, high frame rate USB video capture solutions right now?
Okay, let's go ahead. So actually last year, right, we actually already demonstrated this solution last year, but what's different this year is the this new receiver from IT, what's called the IT66651. Now what they did is adding the loop-through capability into the receiver. So what that translates into the capability is the, so last year the solution just straight from video to USB to capture, right? And that's good for Pro AV. Right, but that's not really nice for a gamer. Right? I don't know if you play game or not, right? So typically gamer they chase for higher frame rate, or higher resolution, low latency, right? So with this solution that the with pass-through, right, they can have 4K 120 frames per second the video going to their nice monitor, right, and then play game in the meantime, right? So the other video pass going to the our solution, and then they capture entire gameplay through USB, and then that can be streamed to the internet or recorded for a later editing.
Wow. So Jimmy, how does your EZ-USB FX20 platform help developers balance throughput, latency, programmability, and power efficiency in next generation embedded vision and industrial applications?
Okay, definitely very, very important things that the so this new building block, right? So of course, number one, that it provides high bandwidth, 20 gig of bandwidth for this USB interconnect, right? So, but for today's this AI focused world, right? So we talk about a few things, right? So power is very important, right? And the FX20 is definitely a very low power device that providing this high bandwidth. If you talk about the power per bandwidth things, right? Or bandwidth per power, that it's definitely much better than any other interface that they are providing the same bandwidth, right? So earlier I would talk about physical AI, right? Which is crucial for the next milestone in the AI, the growth, right? So what physical AI means is the how AI learn from the real world.
Yep.
So those data is getting from the sensor.
Yes,
right?
sensors.
And one of the critical sensor is the vision part
image,
of it, right?
Vision.
And so if you really want a lot of data, high resolution, high field of view, right, or high frame rate, you need big bandwidth.
True.
Right. So what Infineon provide is this FX20 that can provide 20 gig of the bandwidth, and
that's big,
which allow, that's like a 8K 30 frame per second or 4K 120 frames per second bandwidth. That is so the embedded system like NVIDIA that they can acquire tremendous of the video data into the GPU to process it, to learn from this physical world. Right. I think that's going to be a very critical interface that to enable this the physical AI data. So and we actually definitely looking forward that to see more application, more sensor to use our chip to interface to the embedded system.
Okay. So Jimmy, as USB bandwidth continues to scale, definitely, how important are firmware optimization and software stack integration compared with the underlying hardware architecture in achieving consistent real-world performance?
Okay, so to talk about this, we got to go back to, I don't know, maybe 30 years ago that because USB was originally designed for the consumer product, right? And what makes USB successful is the high integration between hardware, software, and especially the operating system, right? So we talk about plug and play, right? This is a real plug and play. You plug in, that you don't worry about the driver installation, right? So, but that's good for the PC world, right? But now moving to the embedded system, which is now dominated by the NVIDIA GPU, right? So that now the people facing the challenge, taking the very mature older generation or use the software stack, right? Now we're trying to optimize it so that the latency from the sensor to the GPU, right, can be as short as possible, right? So this is what the whole industry, including NVIDIA, trying to do with the holoscan, right? So we trying to catch up in this game that to provide the very simple, very low cost connection compared to the whole interconnect industry.
All right. So Jimmy, Asia, as you know, remains the major manufacturing hub for PC, consumer electronics, and embedded. No? So what trends are you seeing among Asian OEMs and ODMs in terms of next generation USB connectivity requirements and product roadmaps?
Okay, so I think we know that the Asia used to be great in the contract manufacturing, right, and building great product for the world, right? And but in the past few years, we learned that the design capability in Asia has grown tremendously. That but still that I think for the product that which one leveraging this bandwidth, and oftentimes because we are general purpose controller, we sometimes depending on the FPGA to interface to other data source or sync, right? So that actually is quite challenging for typical manufacturer, which really used to a turnkey solution to take it. Okay, it's take a turnkey and just packaging and just shipping, right? So now with this next generation of product, right? And you start involving with development into the FPGA code in there, right? And so Infineon that we play a role so that we have a very big the application engineering team that the dedicated supporting customer, right? And we're trying to make this as easy as possible, so that we're actually helping our partner in Asia to move into the next level of the building more complicated and higher bandwidth product.
All right, Jimmy, thank you very much for your insights. Do you have any final comments?
So one thing we're trying to do here is especially this year is the this whole ecosystem of the USB 20 gig, which also called 3.2 Gen 2 by 2. You know, you can see that many people here we talk about USB 4, right? 80 gig, 40 gig, right? So people may ask, why we talk about 20 gig here, right? So
it's big.
So the thing is that there's of course there's history that we can talk for a while. But most important is the yes, we miss that in this industry from 5 gig to 10 gig, 20 gig 10 years ago. And we're trying to come back and rebuild this ecosystem, partner with like S Media, for example, right? And to make this 10 gig and 20 gig ecosystem to grow into the foundation of the next level of 40 gig, 80 gig, or even faster, the 120 gig, right? So this is actually crucial for the entire industry to move forward healthy, right? So you don't really skip from 5 gig all the way to 80 gig, right? I mean,
it's gradual, right?
Exactly. So what the so I think the for Infineon, especially my product line here is the we're hoping, right, this stagnation that the caused in the past 10 years, right? We will caught up and and then we'll move faster that and to meet the high demand of this the bandwidth, power, right, for the entire AI growth.
Exactly. All right, great. Jimmy, thank you very much again for this opportunity.
Okay. You're welcome. Yeah, thank you.
That's Jimmy Cho, Director of Product Marketing at Infineon. I'm Steven Las Marias. Thank you very much for watching.